Okay, in part 9 we're going to look at a more typical use of the mapper and see how the mapper and the Superstack combine to allow more rich interaction patterns. So what we have in this address space is, again, we have a mapper declared and we have our active1 endpoint, and inside the inner space we're showing here that it's just a space like any other, and so what we have here is an import, and we're importing the part 5, the endpoints from part 5. And if you remember part 5 way back up here, the part 5 space contains the subrequest accessor, which is the indirect active1. So whenever this request, this resolves a request, it issues a subrequest for active1. So the grammar that we have defined for our mapping says it's going to resolve alias active1, which is the same as we've seen before, but instead of issuing it directly to active1, which we know would resolve here, we're going to issue the request to indirect active1. So alias is now going to call indirect active1. Indirect active1 is going to be resolved in the inner space. It's going to be delegated by the import to part 5, which will fire up the subrequest, which will issue a request up the Superstack into the inner space. Note find active1 there, but eventually come up the Superstack 2 levels and find active1 here. So let's see that in practice. So if I resolve active1, we see it resolves the mapper overlay. If I resolve, alias active1, that was before. If I resolve active1, we see it resolves to accessor1. And if I resolve indirect active1, we'll find it doesn't resolve because that's not part of this outer address space. It doesn't exist here. Let's just quickly confirm this with the Space Explorer view. Sorry, wrong one. Part 9. So what we see here is the mapper, the accessor, the inner space. The inner space is import, and the subrequest endpoint contained inside the part 5 address space. So this subrequest over here somehow is able to call this accessor over here. Let's find out how that happens. So I need to turn on the visualizer. One day I'll learn to clear it before I do the demos. Start that, and I'm going to ask for alias active1. I'm going to issue it into the part 9 address space. I'm going to request it, and I get active:1. If I stop the visualizer and look at the request, we now see that there were 3 requests happened. Alias active1 was issued into part 9 and got mapped to the mapper overlay. The mapper overlay resolved to the mapper overlay and rewrote the request to indirect active1. We can probably see that more clearly up here. So mapper overlay reissued a request for indirect active1. Indirect active1 was resolved to the subrequest accessor. Let's see how that happened. See, the mapper overlay issued that request. We see that it started in the inner space. It found the import in the inner space, and the import says, yes, I'll deal with indirect access active1 with the subrequest accessor. So the request started here, was resolved to the mapper overlay. The mapper overlay rewrote the request and issued it into the inner space. The inner space resolved the request through the import to the subrequest accessor, and the subrequest accessor received the execution of that request. So the subrequest accessor now issues its request, the subrequest for active1. So the active1 request is made in the subrequest accessor. Subrequest accessor makes a request for active1 just here. But now we start the request in the part 5 address space. So we must start the request here. The subrequest is issued here. We look in the part 5 address space, and of course it doesn't match on the subrequest accessor. We pop the scope and start looking at the overlays inner space, but that doesn't resolve us because it doesn't make any sense. We've been down in part 5 already, so there's no match. So we pop up again. This time we go up to the part 9 address space. Part 9 address space contains the mapper overlay, but of course it also contains the accessor 1, so we find accessor 1 there. So the request using the Superstack, the subrequest for active1 starts here, pops to here, fails to resolve here, pops to here, and resolves on accessor 1. So this endpoint here, which has no knowledge prior to the structural arrangement of these spaces, is able to make a request to this accessor over here. Now, at first glance this seems a little obscure, but it enables us to do some very powerful patterns. So what I'm going to show you is a pattern called the language runtime pattern. So I'm going to import into this space the Groovy language, and I'm going to create another endpoint, and I'm going to call this upper active1. And whenever any request for upper active1 is called, I'm going to call the Groovy language runtime. And I'm going to call the Groovy language runtime with a literal script. This could have been another reference to another resource, or a script in the file system, or a script on an HTTP server. It doesn't matter where the script lives. For the moment, I'm just going to have it in line in here just because it's convenient. And then my script is going to say, okay, I want a string. I'm going to use the context object, and I'm going to source active:1, and then I'm going to create a response from S to uppercase. Okay, I remember to save my module. The change gets detected. I've now got a new endpoint in my system called upper active1. So let's go and look at the space diagram. Let's reload that page. And what do I have here? I have a new mapper configuration. I've got an import, I've got another import here. If I look at the details of this space, we'll see that I've got two logical endpoints implemented by the mapper overlay. So if I go to the visualization, the request trace tool, and I ask to resolve upper active1, what I find is that endpoint I just declared is now resolved on the mapper overlay. I'm going to turn the visualizer on again, start the visualizer, and actually issue a request to upper active1. What I see back is an uppercase version of active1. So if I stop the visualizer and look at how that happened, what we now see is my request for upper active1 was issued into the address space part 9. So using my diagram, I issued my request for upper active I'm going to show the libraries as well, 1 second. This is more helpful. Libraries are by default hidden just to show the details of the space you're working on, but if you turn the libraries on, then you get to see references to imports of libraries that you might be using. So what we can see here is that my mapper overlay has an inner space that's importing our subrequest accessor in part 5, and it's also importing the Groovy runtime and all the endpoints that contains. So my upper active 1 request was resolved to the mapper overlay. Mapper overlay rewrote it to this request. It rewrote it to active groovy plus operator at, and then it referenced a pass by value. That's my literal inline script that I wrote. So let's see what happens to that. To where does that active groovy request go? See, it was issued by the mapper overlay. The request was for active groovy. It was issued into the inner space, and then we see that we've started looking in the it turns out actually we had a value space. That's that literal that I declared. That's not actually requestable because it's transiently inserted by the mapper, and it contains that literal script that I just referenced. But it started looking in that space. It then looked in the inner space. The inner space has an import to the subrequest endpoint, which failed. But then it tries and finds the groovy runtime, langgroovy. If we look inside langgroovy, it went through a private filter, which we'll learn about in a moment, and finds the groovy runtime. So the groovy runtime is resolved, and that's the physical endpoint that we find. Now the groovy runtime, when it executes, it now issues some further subrequests. First of all, it asks for the operator argument that it receives. Remember, it needs a script to execute, so the groovy runtime always asks for its operator argument. In this case, the identifier of the operator argument is this made-up literal reference into that literal space. So it sources the PBV operator, and the PBV operator, if we look at the value, is that string that I put into the mapping. It having received its PBV, it transreps it. So it compiles, it calls the groovy compiler to transrep the string, and it requires a compiled groovy representation. So the groovy compiler compiles the representation, and then the groovy runtime now starts to execute, and it starts to execute the code that I defined. And the code I defined, if you remember back here, is to make a subrequest for active column 1. Okay, so active column 1 is requested. Where on earth did this start being requested? Well, at this point we're inside the groovy runtime down in this space here, and this is the Superstack we have available to us. So the groovy runtime is running the code just here, and the code is saying you need to call and request active column 1. Active column 1 is requested in this space, but it fails to resolve it. It pops the scope and comes and looks in the inner space. It looks at this import, but that doesn't resolve it. It doesn't obviously import in itself, so that's eliminated. We reach the end of this space, pop up the Superstack, find that this space contains the mapper overlay and acts as active 1. So this groovy code over here, even though it's declared just here, is able to run a piece of functionality in the context in which the calling request is made. And that's how active column 1 got its uppercase.